Hello and welcome to Chapter 13. We're talking about point-slope form. So when a linear equation is written in this form of y minus y1 equals m times the quantity x minus x1 in quantity, where y1 is a y coordinate, y value for a coordinate, where m is the slope, and x1 is an x value. Now, as you'll see in some examples, you can go from point-slope form to y-intercept form quite easily. So we're going to be given some examples like write the equation of the line given the following information. Okay, so with our formula we had y minus y1 equals m times the quantity x minus x1. We do not mess with the y's and x's, we only mess with y1s and x1s. So y minus, we're going to see this is y1, this is x1. I'm going to go ahead and label those. So minus 3 for y1, minus the slope, which is 7, times the quantity of x, which we do not mess with, minus x1, which in our case is 2. Now, let's go through and simplify our equation. So, y minus 3 equals 7 times the quantity x minus 2. Okay, so what you want to do now is take this, it's in point-slope form, looks very nice. To take it further, you want to take this 7 and distribute it across everything inside the parentheses. So it leaves you with y minus 3 equals 7 times x plus 7 times minus 2. So let's go through and simplify. You have y minus 3 equals 7x minus 14. To get y by itself, add 3 to both sides. Notice you want to add it only to that negative 14. You don't want to add to the 7x because they do not share similar terms. So when you do that, you're going to have y equals 7x minus 11. And that is in y-intercept form. And up here, it is in slope-intercept form. Alright, so passing through the points 1, 4 and 3, 7. For this, you actually need to find the slope first. To find the slope, you use the equation m equals y2 minus y1 over x2 minus x1. So there's x1, there's y1, there's x2, and y2. So y2 is 7 minus y1, which is 4, over x2, which is 3, minus x1, which is 1. So when you simplify, you have 3 on top divided by 2 on bottom. Okay, now that we have our slope of being m equals 3 over 4, we can now use our point-slope form, which is y minus y1 equals m times the quantity x minus x1. So y minus, and you might be saying, which points do I use? I would just go ahead and stick with what you have written down. So y1 is 4 equals 3 over 4 times x minus 1. It really does not matter which set of points you go with because you're going to wind up with the same equation at the end. But since we already had these labels, x1, y1, I just say for the sake of the problem, go ahead and use those. So go through and simplify. Okay, and now this is in point-slope form. To put it in y-intercept form, take this 3/4 and distribute it across everything inside the parentheses. Y minus 4 equals 3 over 4 times x plus 3 over 4 times negative 1. And To simplify, we have y minus 4 equals 3 over 4x minus 3 over 4. Now to get y by itself, add 4 to both sides of the equation. So it leaves you with y equals 3 over 4x. And you may be saying, how can I add these together, since this is a whole number and this is a fraction? Well, you can think of 4 becoming 16 over 4 as a mixed number. So when you do your math, you should get a positive 13 over 4. I just went through and noticed that I made a mistake with the slope here. It should have been 3 over 2, just as we had originally found. Okay, so for the placement of 3/4 here and here should be 3 over 2. And how that's going to change the answer is that instead of distributing 3/4, you're going to distribute 3/2. And in this step right here, so when you add the 4 to both sides, instead of thinking of it as 16/4, you think of it as 8/2, because that would reduce to 4. So when you finally do your simplification, you should get for the y-intercept 5 over 2. Sorry about that mistake. Okay, and we have 2 more examples left for this section, so let's take a look at these. We have a line passing through these points. We want to use x1, y1, x2, y2. We want to make sure to use the slope formula of m equals y2 minus y1 over x2 minus x1. And that's going to become y2 is 5 minus y1 is 6 over y2 is 6 minus y1, which is 5. And this on top will be negative 1 over 1, so reduces the slope being just negative 1. Okay, now let's use point slope form of y minus y1 equals m times the quantity x minus x1. Now let's plug in the values that we know. Y minus, let's just say keep the same value of 6 for y1 times negative 1 for the slope times x minus x1, which is 5. Okay, so this is considered point slope form at this step right here. Now if we want to carry it on forward to slope intercept, we'll take this negative 1 and distribute across everything inside the parentheses. So when we do that, we have a negative 1 times x minus 1 times a negative 5. To simplify, we have y minus 6 equals a negative x plus 5. To get y by itself, add 6 to both sides of the equation. That's going to leave you with y equals negative x plus 11. And finally, for our last example, we have an undefined slope passing through the points 4, 9. So what happens for that? Let's let x equal a, since an undefined line is going to look like this on the 4-quadrant plane. So denote the black lines as the 4-quadrant plane. And that means every value is going to share the same x components, but the y components will just be in single file 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. So for this case, x is just equal to the x value of 4, since the slope is undefined.